I often like to use the periodic table as a guide for writing my electronic configurations of the elements. And the guide that I think of kind of works like this. These first two columns of the periodic table, these are going to represent what we're going to call the S block of elements. Just these two columns here, and helium as well. This portion of the periodic table over here, from boron through neon, this block right through here, we're going to call this the P block of elements. The transition elements here in the middle, we're going to call this the D block of elements. And then the elements down below, the rare earth elements, the lanthanides and the actinides, we're going to call this the F block. And I have each block labeled with the principal quantum number for each particular orbital that we're going to be talking about. And you should notice that the S and P in each row, they have the same principal quantum number as the period that you're in. So here's the first period, 1s. Here's the second period, 2s, 2p. In the third period, we have 3s and 3p. In the fourth period, we have 4s and 4p. In the fifth period, we have 5s and 5p, and so forth. The D block, on the other hand, that's always going to be 1 minus the period. So if we look here, I'm in the 1, 2, 3, 4th period. If I move over to here, I'm going to be in the 3D. In the fifth period, I'll be in the 4D row. In the sixth period, I'll be in the 5D row. And in the seventh period, I'll be in the 6D row. And what you'll notice is after you get to 6s, you'll then go one element into the 5D and then drop to the 4f. So you should notice that you'll go 6, you'll start here in the 6th period and drop to the 4f. So you'd be 2 removed, and then the 5f comes when you're moving through the 7th period. We'll show you how that works here in a second. But let's just say that I want to write the electronic configuration for Meitnerium, element number 109. Boy, that looks like it's going to be a mess, doesn't it? Well, let's use our periodic table as a guide. So I'm going to go ahead, let's see, Meitnerium. How many spaces in through the D elements in the 7th period is that? So let's see, we'll be here. 1, 2, 3, 4, 5, 6, 7 spaces in. So let's be here. 1, 2, 3, 4, 5, 6, 7 spaces in. This is the element that I want to write the electronic configuration for Meitnerium, element number 109. And we're going to start. We're going to go through the periodic table. We're going to start with hydrogen, which I'm going to write 1s. And we're going to write 1 electron spin up, and that's going to represent my electronic configuration for hydrogen. Now we'll do it for helium. You'll notice I'm still in the 1s. I'm still in the first period, so I draw my arrow down. Now when I move to trying to find the electronic configuration for lithium, I notice I've run out of the 1s and I have to move to the 2s. And you'll note I'm in the second period in the S block. So I put 1 electron in here for lithium, and if I move here, I can write the electronic configuration for beryllium. If we want to draw these elements, boron, carbon, nitrogen, oxygen, fluorine, and neon, I'm going to need to get out of the 2s and move over here to the 2p. And these all have 3 orbitals into which 2 electrons can go. So this would be my 2p. And I can write my electron now for boron, carbon, it's here, nitrogen would be here. Notice I'm putting the electrons in different orbitals, aligning their spins. Oxygen, fluorine, and neon. When I get here, I've filled the 2p. I'm going to move down from neon to my next element, which is sodium. Sodium's element number 11, and that's going to start the 3s. sodium, magnesium, and those two fill the 3s orbital. So I've got magnesium. Now I'm going to move over here to aluminum. So I'm now going to fill the 1, 2, 3. This is the p block. So I'm going to start to fill the 3p. There's always 3 orbitals in the 3p. And I can fill here aluminum, silicon, phosphorus, sulfur, chlorine, and argon. And now I've written the electronic configuration for argon. I've run out of the 3p. I'm going to move to the next element, which is potassium. When I write the electronic configuration for potassium, I have to start filling the 4s. So here's my 4s, and that's going to be potassium and an electron for calcium. So now I'm here. Now I'm going to move to scandium. Well, scandium starts to 3D, doesn't it? So we're going to put 1, 2, 3, 4, 5 orbitals in any d subshell. And then we're going to start. Scandium gets an electron here. Titanium. Vanadium. For chromium, we're going to remember, for chromium, we'd actually would place 5 electrons in the 3D and lift one out of the 4s. Got to remember to do that. So let's see, scandium, titanium, vanadium, chromium. And then for manganese, we're just going to do that. Let me move to iron, cobalt, nickel, copper. Again, for copper, we're going to lift this electron out of the 4s and fill our 3D subshell and have a half-filled 4s. So it's going to be 4s1, 3d10 for copper. And then zinc, we'll have it filled like this. And now we're here on the periodic table. All the way to zinc. Now if I want to do gallium, I have to start filling the 1, 2, 3, 4. This is the p. So I'm going to start filling the 4 p's for gallium. Well, I kind of run out of room here, so let's start up here. Let's do 4p. Okay. So I'm sitting right here. Gallium, germanium, arsenic, selenium, bromine, and krypton. And I filled all the way through the 4p, and we're sitting here at krypton. The next element's rubidium. I've run out of the 4p. I'm going to move here to the 5s, and you can see that on the periodic table. 1, 2, 3, 4, 5, and I'm in the s block. So I'm going to go ahead and put 5s, and I'm going to fill rubidium, strontium. Rubidium spin up, strontium spin down. Now I'm going to move from this 5s into the 4d. We're going to move to yttrium here in the 4d. And the d subshell, that's going to get 5 orbitals in the, sorry, I said 5d, 4d subshell. And you can see I'm going to start to fill in all these elements here, yttrium through cadmium. So here we go. We're going to go yttrium, zirconium, niobium. You can probably imagine at molybdenum, we're probably going to lift that electron out of the 5s and have a half-filled d subshell and a half-filled 5s. And of course, that's what happens. And then we have technetium. Let's see, yttrium, zirconium, molybdenum, yttrium, zirconium, niobium, molybdenum, technetium. And then we have ruthenium, rhodium, palladium. Once again at silver, we're going to lift this electron out of the 5s and fill the 4d. So it's going to be 5s1, 4d10 for silver. And then cadmium, we'll have it filled. At this point, at cadmium, I have run out of the 4D subshell, and I'm going to move into this area, which would be the 1, 2, 3, 4, 5P. I'm in the P block now for indium. In the P subshell, we're going to have 3 orbitals. And so we fill in, starting here at indium, tin, antimony, tellurium, iodine, and xenon. So I'm all the way to here at xenon. So I'm going to move here to cesium. What orbital will I be filling? Well, 1, 2, 3, 4, 5, 6. So it's going to be the 6, and I'm in the S block. So I'm going to start filling the 6S right here. 6S. Cesium, barium. I just filled these two. And now we're going to move here to lanthanum. Let's see, I'm in the 1, 2, 3, 4, 5, 6th period. And we remember that when I enter the D here, when I enter the D subshell here, that I'm going to be 1 less than the period I'm in. So I'm in the 6th period, and I start filling this D subshell. So this must be the 5D subshell moving across here. So I'm going to write in the 5D. 1, 2, 3, 4, 5. And I'm going to move from 56 to 57 lanthanum. I'm going to go ahead and stick an electron in the 5D. After 57, I've got to move here to 58. So I'm moving here from the 5D to the F, and this is the 4F subshell being filled across here, and this is the 5F subshell being filled across here. And the F has 14 elements in it because there's 7 F orbitals. So I'm going to go ahead and write in 1, 2, 3, 4, 5, 6, 7. This is going to be the 4F. Wow. Okay, so we just put this electron in the 3, 4, 5D. Go from 57 to 58. I've got to go here to the 4F. And now we can start filling in those electrons. It's going to be cerium, praseodymium, neodymium, promethium, samarium, europium, gadolinium, terbium, dysprosium, holmium, erbium, thulium, ytterbium, and finally lutetium. I have filled in the 4F. I'm going here from number 71 all the way back here to number 72. And notice I'm going from the 4F back to the 3, 4, 5D for hafnium. You should also recognize that there's a lot of exceptions to the normal filling rules as you move through the 5D, the 6D, and the 4 and 5F. Just know that. But this gives you an idea of how the various electronic configurations are achieved. Don't worry about it being perfect for this case. Nevertheless, we're here at hafnium, tantalum. Now notice I'm putting the electrons, I'm always putting electrons in different orbitals first with their spins aligned. That's following Hund's rule. Tungsten, rhenium, osmium. Now I'm starting to pair them up because I've run out of space. Iridium, platinum, gold, and mercury. Wow. Okay, now we're moving on to thallium. Well, I wonder what orbital that would be. Let's see what row I'm in. 1, 2, 3, 4, 5, 6, and this is the P block. So I'm going to be filling the 6P now. 6P. Thallium, lead, bismuth, polonium, astatine, radon. And what's nice about this filling order is you're always going to get the right electronic configuration for the main group elements. And you might remember the main group elements are those that are found here in these two columns, which is the S block, and those that are found in these 6 columns, which is known as the P block. You'll also get the right electronic configuration for many of the transition elements, although not all of them. So what are we? We're here, radon. That's number 86. I'm going to move here to 87. What period am I in? 1, 2, 3, 4, 5, 6, 7. And I'm in the S block. So I'm going to start that here. 7S. Francium. And then radium. I've run out of my 7S. I'm going to move here to actinium. That's in the 3, 4, 5, 6D. And that 6D is going to have 5 orbitals. 6D. I'm going to place 1 electron in here for actinium. And then I got to go from 89 to 90. I got to go down here to the 5F. And the F's have 7 orbitals. So I got to draw in the 5F next. That's going to have 7. 1, 2, 3, 4, 5, 6, 7. 5F. Now we can move across our F electron. So notice I just put this electron in, the D, for actinium. Now I'm going to go down here for thorium and start putting electrons in the 5Fs for thorium, proactinium, uranium, neptunium, plutonium, americium, curium, berkelium. Now that I've run out of these orbitals with 1 electron spin up, I'm now going to start pairing them up. Of course, I forgot where I was at, so let me count again. Thorium, proactinium, uranium, neptunium, plutonium, americium, curium, berkelium. So now I'm on californium, einsteinium, fermium, mendeleevium, nobelium, lawrencium. I'm at the end here, and I've run out of the 5F. So I'm at element 103. I'm going to move all the way back up here to element 104, which is back to the 1, 2, 3, 4, 5, 6, 7 Ds. Excuse me, that would be the 7th period, but it's going to be the 6 Ds. So I'm starting here with element 104. That's rutherfordium, dubnium, seaborgium, borium, hessium, meitnerium. That's going to be the electronic configuration for the element meitnerium, which we can write in SPDF notation. Let's do that. Boy, that's going to be a bugger. So it's going to be 1s2 right there, 2s2, 2p6. I'm going to cross them off once I do them. 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 5d10. We'll continue on the next line. That's 4f14. The F's get 14 if they're filled. 6p6, 7s2. Looks like 6d. Let's count them. 1, 2, 3, 4, 5, 6, 7. This could be 6d7 and 5f14. Wow, that's the SPDF notation for the element meitnerium. It's a lot easier to write this in the noble gas configuration. What we do there is we're going to take the nearest noble gas to meitnerium, which is radon. So I'm going to go ahead and draw in a bracket radon. It's going to look like this. Let's see, radon, like that. And then I have to think of which of these electrons correspond to this, in brackets, radon. Well, let's see, radon has all the way through the 1, 2, 3, 4, 5, 6p subshell filled. So let's see, that's all the way through to here, right there. So everything that's doubly underlined is represented in this radon in brackets, because what I've doubly underlined, that's the electronic configuration for radon. And then I just write 7s2, 6d7, 5f14. That's a lot easier to write. The noble gas shortcut for the element meitnerium, atomic number 109.